natural logarithmic function f of x equals to log. This time we are using a natural base e of x. So when the base is e, the log base e becomes ln of x. We will just say ln of x. Now, what is the graph of ln of x? We are going to show you right now. Before we start, ln of x has a graph. The inverse function of ln is the exponential function e to the x, and then e to the x is the inverse of ln. ln is the inverse of e to the x. Basically, they are the inverse function of each other. We are going to talk about the domain next. So before we get into that, ln of x, the graph is very similar to log of x, right? They are both logarithmic function. The graph of ln is very similar to log. In fact, they are not the same. We will talk about that when we get to the image on the right. Now, how do I get this point? I use decimals to create this graph. On decimal, after you input y equals to ln of x, y equals to e to the x, there is an gear icon on the upper right hand corner. Click the gear icon and then you will see a table icon. Click the table icon. Now you can select x value. So for ln of x, you can select x equals to 0.5, x equals to 1, x equals to 2, x equals to 3, 4, 5, 6, 7, 8, 9, 10, whatever you want. As long as your x value is within the domain, there is a corresponding y value. So in my graph, I selected 0.5, 1, 2, and 3. So they gave me a corresponding y value, and then they will show the point as well. So move the cursor to the point, click on the point, and then they will tell you exactly what the coordinate is. So that is how I got the graph and the points and the x and y coordinates. Now, what do you see here? The graph of ln is an increasing function, and what else do you need to know? The domain is x greater than 0, so the interval is from x to positive infinity. This is because there is a vertical asymptote right over here. So for ln of x, there is a vertical asymptote. I just do VA for vertical asymptote at x equals to 0. So as x approaches to 0 from the right, the ln of x approaches to negative infinity, which is this corner, right? It just goes all the way down to negative infinity. So the vertical asymptote is right over here at x equals to 0. So that's why the domain x must be greater than 0. There is no equal, because when x is equals to 0, there is a vertical asymptote. And then the range, y can be positive, negative, and 0. So that's why for the y that goes from negative infinity to positive infinity. So let's review the exponential function e to the x, the blue graph. So the e to the x, same thing. I graphed the e to the x, and I also gave you the points. And then for the domain, e to the x, x can be any values you want because you are selecting an exponent. And then for the y is greater than 0. So this is because there is a horizontal asymptote at y equals to 0. So you don't say y greater than or equal to 0. There is a horizontal asymptote right over here. So as x approaches to negative infinity, y approaches to 0. And then what about y equals to x? Y equals to x helps me to show that ex and ln of x, they are the inverse function of each other, because y equals to x allows them to exchange the x and y coordinate. Let's take a look. Now, the first point that I want you to look at is 1, 0 and 0, 1. Do we agree that from 1, 0 to 0, 1, they swap the x and y? Yep. And then the next point is 2, 0.6 and 0.6, 2. The x and y, they got swapped. And then 3, 1.09, 1.09, 3. They swap the x and y. Do you still remember why? Why is this true? The y equals to x is like a mirror. So let's say you are standing in front of a mirror, you are taking out your left hand, and then you are using your left index finger to touch the mirror. Now, just picture this in your mind. At this point, you see that your reflection is also using the finger to touch the mirror, right? Now, you are using your left hand, your left hand touching the mirror. Do we agree that if you take the perspective of your reflection is using the right hand to touch the mirror? In other words, you are standing in front of your mirror, your left hand is actually the right hand of your reflection. So the mirror allows you to use your left hand to touch the right hand of your reflection. That means they allows you to interchange left hand and right hand. Back to the function, y equals to x, they allows you to interchange the x and y coordinate. And then for y equals to x, here, do you still remember this? The domain of f is equal to the range of f inverse. The range of f is equal to the domain of f inverse. So let's take a look. The domain of f, x greater than 0, is equal to the range of the inverse function, but except you have to change from x to y. And then also the range of f is equal to the domain of f inverse. They are both from negative infinity to positive infinity. Do you see that how they exchange? That's why we have y equals to x. So the y equals to x is like a bridge that helps the f and its inverse to exchange the domain and range. All right. Okay, moving on to the comparison of natural logarithm and common logarithm. Common logarithm is the log and the natural logarithm is the ln. The graph, they look the same, but in fact they are not the same at all. They are only the same at the x-axis when x is equals to 1, right over here. They are equal at x equals to 1. Otherwise, they are not equal. So when x is greater than 1, we can see the ln is greater than the log. When x is between 0 and 1, the log is greater than the ln. Right? So they are not the same. They have the same shape, but the natural log and the common logarithm, they are not the same at all. And then I also have an image right over here that shows you a couple estimation. So ln1 and log of 1, they are both equals to 0. ln2 and log of 2, they are not the same. One is 0.69 and the other one is 0.3. Log of 3, they are not the same at all. And then how about the last line? Log of -5. How come this is an error? Because for ln, x must be positive. ln of negative is undefined. Right? So ln of negative is undefined. Also, for common logarithm, log of negative is also undefined because for both functions, there is nothing on the other side of the y-axis. What do I mean by on the other side? On the left-hand side of the y-axis, x are 0. Do you still remember that? There is a vertical asymptote. There is a vertical asymptote at x equals to 0. That means the curves, they will not pass the vertical asymptote. So there is nothing on the other side of the y-axis when you evaluate ln of or log of negative. None of those is defined. Okay, moving on to the properties of natural logarithm. We have 4 properties. They are very similar to the common logarithm. ln of 1 is equals to 0. So for ln of 1, they do not specify the base, but there is a base e in there. You have to know that, but you never write the base. So this is e raised to the 0 power equals to 1. Oh, actually I make a mistake right over here. So let me correct that right now. So I'm going to correct my mistakes. It's e to the 0 power that is equals to 1. I was writing too fast when I was preparing my notes. E to the 0 power, should not make the line that bold. E to the 0 power is equals to 1. And then the other one, number 2, ln e is equals to 1. This is because base e, I color coded the base for you. So base e, the green base, raised to the first power, that is equals to e. All right, number 3, ln e to the x is equals to x, and then e to the ln x is equals to x. That is called the inverse properties. And then number 4, if ln x is equals to ln y, then x is equals to y. This is called one-to-one property. They are very easy to use. Now, e ln of 5, what is that equal to? ln of phi. So using which one? Using number 3, ln e to the x is equals to x. So this is ln of phi, then that is equals to phi. And then ln e, and then you raise to another ln e. What is that equals to? So we will be using this. Ln e to the x is equals to x. Oh, here, sorry. Ln e to the x is e to the x. So this is just equals to the exponent, which is ln e, right? So what is ln e equals to? Ln e is equals to 1. So ln e, this is equals to 1. And then e raised to some exponent. So this time we are following this. E to the ln x is equals to x. So this is equals to 1/3. And then the last one is a 1-to-1 property. ln 3x minus a is equals to ln a. They are both ln. They are both base e. Then 3x minus a is equals to 8. Add a on both sides. So 3x is equals to 16. And then what is x? X is equals to 16 divided by 3. All right. And then we have more exercise to do, logarithmic form to exponential form. How do we do this? Now, we have a bunch of ln. What is the base of ln? The base of ln is, I'm going to use a different color. The base is e, the base is e, the base is e, right? So for exponential form, you will have a base e right over here. I'm going to write this out first and then use the yellow color to do the rest. So this is e to the negative 1.099 equals to 1/3. And then e raised to the 1.792 equals to positive 6. And then e raised to the what? E raised to the what power is equals to negative 3. Is this possible? The answer is no. We just mentioned that ln of negative is undefined. So back to the graph of ln and log. Do we agree that there is nothing on this side? So for the graph of ln and log, when x is negative, nothing is defined, right? So go back to our problem. So this problem is asking, hey, e to the what power is equals to negative 3, which is equivalent to, hey, 2.7 multiply itself a few times equals to negative. Is this possible? The answer is no. So this one has no solution. So this has no solution. Impossible. 2.7 is positive. Multiply itself a few times. You are not going to get a negative. All right. So moving on to the right. So we have exponential form back to logarithmic form. Okay. So let's use a different color to do this. So for logarithmic form, we have ln what? ln 0.513 equals to negative 2/3. Remember, we have a e right over here and then a e right over here. So e raised to the fraction is equals to the decimal. Next, we have ln. So this one is ln what? ln 1 equals to 3 to the x. And then where is the base e? The base e is right over here. So e raised to the 3x is equals to 1. Okay, last one. This is a ln 2 equals to negative 4x, right? Where is the base e? The base e is right over here and then right over here. E to the negative 4x, that is equals to 2. All right, so that is the end of this video. If you like the way I introduce natural logarithmic function, give me a thumbs up, give my channel a subscribe. I will meet you all in the next lesson for more math content. Signing out.